Black math! Give me some math and I'll give you some flack. Black math!
We're multiplying rational expressions. So first step is factor. All right, so now that's completely factored. So now we've got this one. There is a common factor there, right? X plus 3. And then over here, there's no common factor. There's no difference of 2 squares. So the last one is our fun one, the riddle. What two numbers multiply to get negative 15 but add to get negative 2? Can you think of it?
Huh?
Nathan, what do you got?
5 and negative 3.
Close. Negative 5 and positive 3, right? It's got to end up with a negative. So you got the right numbers. That's a very common issue, is just make sure the bigger one is negative if you end up with a negative. If this was a plus 2x minus 5, it would have been 5 and negative 3. All right, now I take out my red pen.
Wait, does it matter that? Like, why does it matter which one is negative?
Because when you FOIL it out, you get x squared positive 3x and negative 5x. And you have to end up with a negative 2x. So negative 5x added to a 3x. So it doesn't matter for the negative 15. Okay, but it does matter to get the end up with a negative 2 instead of a positive 2. Okay, so now I take out my red pen and I have some fun. What can cross cancel? What can vertically cancel? What can cancel?
X plus 3.
X plus 3 cancels with this x plus 3. Nice. What else?
And
Nathan?
X minus 5.
X minus 5s can cross cancel. Good. And there's one more.
Is it the
You see it, Micah?
X?
Yeah, just an x right here. See this x and this x. Okay? Because those are factors because they're being multiplied. Okay, so now what are we left with? Now we just go straight across. We just have an x plus 5 on top and an x minus 7 on the bottom. Tell me that's not at least a little bit satisfying. We went from this crazy multiplication problem to a cute little x plus 5 over x minus 7. Doesn't that satisfy your soul? At least a small percentage of satisfaction. Okay. All right. Good. Good. Let's try one. Let's see if you can do this one next one by yourself. Example 2. X squared plus x minus 6 over x squared minus 4x minus 21 times x squared minus 8x plus 7 over x squared minus x minus 2. All right, see if you can do that one. So no greatest common factors in this one, no difference of 2 squares. So you're just just doing factoring trinomials and seeing what cancels. You're going to end up with a cute little binomial over a binomial, just like we did in the last one. It's always a little disappointing when you're left with like a couple binomials over a binomial and you don't get to cancel almost everything. But that's okay. Sometimes you do these and you get like 4. Just really satisfying. Because you can factor out numbers and then everything else cancels. It's just beautiful. You guys still working? Micah's trying to do it all in his head. Look at him. You doing it in your head? How do you keep track of all that? All right, so I'm moving in. I'm going to go slow. You keep going. We'll start factoring. Okay, what's your number? Okay. Plus 3. So you guys got when you factored? No?
I was confused from what I was doing.
So you guys got? Nice. All right, is that what you got, Elkin?
Okay, I got the top left one.
Nice.
And then, okay, I don't really know if this matters, but for the bottom left one, I got x minus 7 and then x plus
It
3.
doesn't matter what order you do it in. It just matters what sign.
Okay, so I
goes
got that
with
one.
Yeah.
And then that's x minus 7. And I got that one. And then x minus 2.
Nice.
Yeah, I got all of
Good
them.
job. All right, so now we have fun. Let's see, x plus 3's cancel on top of each other. X minus 2's cancel diagonally. X minus 7's diagonally. Look at that. Beautiful. And we almost were able to cancel the x minus 1 over x plus 1, but you can't do that. They have to look exactly the same. So there's your answer. That was nice. Right? Right? Okay. All right, so guess what? If you can multiply these, what's the only difference with dividing? You just copy dot flop. It's the same thing. Okay? So if you can multiply rational expressions, you can divide them. All you have to do is copy dot flop. It's just one silly little step. Okay? So let's try that. Let's try example 3. You can kind of squeeze it over here. X squared minus 2x all over x squared plus 2x minus 8 divided by x squared plus 5x all over x squared plus 7x plus 12. Okay, first step, copy dot flop. So you could rewrite it if you wanted to, or you could do this. You could change that to multiplication and then factor this one up here. So this is x plus 3, x plus 4, and then factor this one down here. Take an x out and it's x plus 5. You see what I did? It could be a little dangerous if you do too many steps in one thing, but see how I factored this top one down here, and I factored this bottom one up here. So I copy dot flopped the same time as I factored, okay? So we still need to factor this. This is x times x minus 2, and this is x, let's see, what is it? Plus 4, x minus 2. So now we cross cancel with the right ones, because you can't cross cancel when it's a division problem, right? You can only cross cancel when it's a multiplication problem. You can now. So let's see, the x plus 4s cancel, the x's cancel, and the x minus 2s cancel. So you're left with just an x plus 3 on top and an x plus 5 on the bottom. Pretty cool, right? So division. They're going to try to make it more difficult, but they can't. If you know how to multiply fractions, you know how to divide. Let's do one more and then we'll move on. See if you guys can do this on your own. Here's example 4. This is x squared minus x minus 6 all over x squared minus 3x minus 10 divided by x squared plus 5x plus 4 all over x squared minus x minus 20. So this will end up nicely too, a binomial on top, binomial on the bottom. I think there's one on a test, which is so disappointing. There's one on a test that does not end up like this. You have like two binomial, you end up with 2 extra binomials. It's just disappointing.
So we have one more test though.
Yep, one more test, so probably on that test. All right, see if you can do that one. Micah, I'm gonna ask you first, see if you got it. I'm so curious to know if you can keep track of all this in your head. I'll be very impressed. I have too much stuff in my head because I'm so smart, so it's hard to keep track of new things that go in there. There's not enough room, like a waiting list. Ethan, do you think I'm smart? Okay, because you didn't react when I said smart. I guess that's a good thing. Didn't object to it. I'm pretty attractive too. Oh, you reacted to that, so that must mean I'm not attractive. Maybe one day, not to come, but. All right, I'm gonna just let you work and see what you got. Do you have an answer yet, Micah? Because I'm talking? All right. Still working, Micah? All right, let me know when you have one. I want to know. I would love to know. You have an answer?
Well, not like an answer because I haven't canceled them out, but I have exponents. Or not
Factor.
exponents, but my factors stuff. This is my factory.
Yeah. What? And then I forgot you have to copy that file. Nice, dude. That's all factored correctly.
Yes. I struggled with the last two, the one on the right,
Yeah.
because I didn't like 20 and 1.
What's that? What's that?
I got confused with the 5.
Oh, this one. This one is not right. The bottom is not right.
Yeah. I'm confused with all the exponents with the factor.
Yeah, those should both be positive. Yeah, I think that's right. Such an artist. Your handwriting, like, it's just so flowing. Sometimes hard to read, like a classic artist. Yeah. And double. Yeah, that's right. All right, are you ready, Micah? All right, that's okay. Let's do this. I'm gonna factor. So this is x minus 3, x plus 2. Okay. Here's an x minus 5, x plus 2. This is all positive, so x plus 1, x plus 4. Oh, did it upside down. X plus 1, x plus 4. And then here's x minus 5, x plus 4. Cancel. There's a lot of vertical cancellation here. So x plus 4 is cancel, x plus 2 is cancel. And then the x minus 5s cross cancel. And you're left with x minus 3 over x plus 1. That feel all right? Okay.
I got that except for x plus 2. I was off like the bottom.
Oh, okay. Yeah. So lots of details. So be careful. If you need to FOIL it back out to make sure you factored it correctly, then do so, especially on a test. All right. Next, we are going to talk about the next version of uniform motion. So remember the uniform motion that we've talked about last week was where the two distances are equal. So you're like D1 equals D2. So then you substitute the R's and the T's, so you get R1 T1 equals R2 T2, right? So now we've got a different scenario. Let's say that they're not equal. Let's say that they add up to something. Okay, so this uniform motion is version 1. What we've talked about so far is D1 equals D2. Uniform motion. Okay, so here's the different versions. 3 versions of what we're going to talk about in this curriculum anyway. D1 equals D2. What we're going to talk about today is D1 plus D2 equals a constant. And usually when you talk about a constant or a scale factor, you say K. And then version 3 is D1 plus K equals D2. But today we're just going to talk about this scenario. And this is where like 2 trains leave the same station. Okay, and then So at what time will they be 100 miles apart? Okay, so D1 plus D2, train 1 plus train 2 has to equal 100. Okay, so let me give you an example. We're going to do 3 examples and then we'll call it a day. So southbound bus leaves at 9 a.m. So south bus leaves at 9 a.m. Okay, so here's the station. So far we've got a southbound bus. And we'll call that DS, distance of southbound, okay? So these diagrams just talk about the distances. They don't talk about rates or times. They just talk about, like if you were seeing an aerial view of these 2 buses, this is what it would look like, okay? 9 a.m., 2 hours later, northbound leaves, not Sieves, leaves, same station. Okay? If the buses traveled the same speed, and were 352 kilometers apart at 2 p.m., find their rates. Okay, so this is a lot of information, and this is the one you read on the test and you start sweating before the end of the problem, okay? But the way we do this makes it so easy. So don't try to math this, all right? Pause your math for just a minute, and let's look at what we need. We need RS, we need RN, we need TS, and we need TN. Okay? That's what we need. So let's just start from the beginning. Southbound leaves at 9 a.m. What kind of information does that give you? The time it left, and if only you knew what time it stopped or what the end time. And guess what? You do. So they actually give you a number, 9 a.m. to 2 p.m., right? So what was southbound's time?
5 hours.
5 hours. So it's not like TS equals TN plus or whatever. It's 5 hours. You just have to do the math to figure out that. All right, 2 hours later, northbound leaves the same station. So what's northbound's travel time?
3 hours.
Yeah, so don't reverse that. Don't say 7, because when I see 2 hours later, my mind tries to add, right? But no, 2 hours later, northbound slept in, was a little late, and 2 hours later, so 2 hours later was 11 to 2, which is 3 hours. Okay, so you already have 2 numbers for your 4 variables. That's nice. Okay, now here's the other good news is the buses traveled at the same speed. So what can you say about either RS or RN?
You do the equal.
Yeah, thanks for raising your hand. We know that's what you're gonna say. So now we can it doesn't matter which one you solve for, but you have to pick a variable to leave on the board, okay? You can't say RS equals RN and then RN equals RS, because then you'll be left with 2 variables. I'll show you in a second. So now we're going to create this equation. What is K?
Constant.
Yep, what's the constant in the problem? 352 miles apart. So this guy leaves here, right? And this one's going to be shorter because they slept in, right? So this is D of N, but the whole distance is 352 kilometers apart. Okay, so now we can see by looking at this diagram, ds plus dn equals 352. So far, so good? All right, so ds plus dn equals 352. Now what do we do?
Whoa.
Micah.
Divide 352 by 8 combined times.
Oh, so you're doing it a different way. So you divide it by 8 in combined times. Okay, we'll see if that works at the end, but how do I want you to do it?
D equals 8 times time.
Yeah, so we're going to replace the d's with r's and t's. So replace ds with rs/ts. What's rs? Rn. And what's ts? Oops. Let's just write it like this first, and then we have a nice progression of stuff. So basically, you don't have to actually put the d equation, but it's just a nice. There we go. Rn Tn equals 352. So far, so good. Does that make sense? So Rs is Rn. Ts is 5. Rn, you have to leave it. So you don't want to put Rs here. Because if you put Rs there, then you're going to have two variables again. So you have to pick one that you're going to be left with on the board. So this is 5Rn plus 3Rn, which is what, Micah?
8Rn.
8Rn. So that's why we're dividing by 8.
How did you get that second row?
So I just I went into my key here. So I kind of made like my own legend, my own key. And so I just replaced Rs with Rn. I replaced Ts with 5, and I replaced Tn with 3. Right? So here's Rs.
Since Rs equals Rn, you just did
Yep.
Rn, and then Ts
Yep.
equals 5. So it's
Yep. And so then, but you have to be careful when you get to Rn, you don't want to say Rs, because then you'll still have two variables on the board. So you're deciding, once you write this, you're deciding, okay, Rn is going to be the one I'm going to solve this equation for. Okay, so now we divide by 8, just like Micah said. I'm going to get 44, I think. Yep. Yes.
Isn't that the rate of going 1 hour?
Kilometers an hour. Yep. Yep. So now we're just asked to find the rates, and we just did, because guess what? Rn equals Rs. So let's just make sure it works, shall we? So Rn traveled for 3 hours at 44 kilometers an hour. So what is that? 132 kilometers. And then southbound train traveled for 5 hours at 44. So that's 220-ish, I think. So 220 plus 132 is 352. That works. See what we did? Okay, now you didn't really think too much about the train and about, okay, let's see if they're leaving this much. I mean, you can if you want, but, you know, pack some ibuprofen because you're going to give yourself a headache. But this does most of the thinking for you. You just have to remember how to substitute. You have to remember how to solve an equation using the steps to solve an equation. But it makes it easy. Okay, let's try another example. So remember, we're doing D1 plus D2 equals a constant. So that's kind of what you have to look out for. All right, so when you read the problem, you kind of see, oh, there's my constant. So those two have to add up to it. And in your homework, you know the nice little, in your homework when it has like the number underneath the problem, that's going to be a nice, because if you see 94, then it's going to be one of these problems. And what was the other uniform motion, like 89 or 90 or something? When you see like 89 or 90, then it's going to be one of these problems. So you can kind of cheat the system a little bit, all right, and know what kind of equation that you're going to write based on what numbers underneath the problem. And on the test,
There's numbers underneath the problem.
Yeah, well, it shows where it was first mentioned, like, so those numbers are the chapters that it was taught in.
all right, ready? Train starts at 11 a.m. from Toledo to Mackinac, 352 kilometers away, 352 kilometers away.
It's just red miles.
I know, we're in Toledo. I guess they're kind of close to Canada there. But, so they're probably confused. Isn't Toledo? Where's Toledo? I don't know.
In Europe.
Let's just call it Canada.
Technically,
I'm embarrassed for Toledo people.
There's the world uses
Toledans.
kilometers and stuff.
I know.
And actually, that used to be like another system, and then they started using the metric system.
We're the only one that uses
We're like the maybe one other country
There's
uses.
2 countries that use the.
We're the only ones left because we're stubborn. But it would cost us a lot of money. We don't really have a lot of money. So train starts at 11 a.m. Okay, 332 kilometers, 300, not 52, 332. Okay. All right. At the same time, 11 a.m., right? Train leaves Mackinac to Toledo at 65 kilometers an hour. So this gives you the rate of that next one. If trains meet at 1 p.m., then what is train one's rate? Train one's rate. Basically the Toledo train that left Toledo to Mackinac, okay? So let's write our diagram here. So here's Toledo. Here's Mackinac. So this is train one. We'll call it train Toledo. You guys good with that? I don't know which one's going to be faster.
Well, one's going 65 kilometers an hour. So
Yeah.
So we know the rate of Mackinac.
Yeah. So basically, this is when they're going to crash and die. Okay. So here's distance of Toledo and distance of Mackinac. What do they have to add up to?
332.
Yep, because the distance between Toledo and Mackinac is 332. Okay, so that's the hardest part, I think, is trying to figure out what that diagram looks like. You don't have to draw the diagram, but it's nice to see. You can literally see that dt plus dm has to equal the distance between Toledo and Mackinac. Okay? All right. So let's get our R's and T's. Do we know R of Toledo?
No.
No, we don't. Do we know R of Mackinac?
Yes.
Yeah, it's 65, right? Do we know T of Toledo? Yeah.
2 hours, right?
2 hours, 11 to 1. Do we know T of Mackinac? Same thing. They left at the same time. Okay. So make sure you don't put the time of Toledo as 11. Okay. Some people make that mistake. Just because 11 a.m. is a time, when we say time, we say how much time was passed. Okay. Not like what time it is on your watch. All right, so now we've got 3 numbers to replace variables. That's awesome. This is going to be the easiest one yet. So RT TT plus RM TM equals 332. Okay? What's RT? We don't know. That's the only one we don't know. But we know TT, it's 2. So I'm going to say 2 RT plus RM, which is 65, TM, which is 2, equals 332. See what I did there? This is 2 kinds of substitution. I put my D equation first, and then I substituted the D's with R's and T's, and then I substituted the R's and T's that I have for the R's and T's, okay? So this is 2RT plus 130 equals 332. Subtract 130. So 2RT equals 202.
222.
No, 2.
202.
And then
Oh, I wrote 352.
10.
Where did I get 352?
So the rate of the
That's
Toledo
what you
train, really? Was it booking that fast?
Why couldn't they
One-
stay like steady
kilometers.
100 miles an hour?
Oh, I guess it's kilometers, so it's like 60 miles per hour.
Yeah.
Why couldn't they stay steady 100 kilometers an hour?
Yeah, doesn't that bug you? 101, that's like the worst. It's like a monk episode gone bad. Did I tell you about one of my favorites? He like goes into the bank to cash a check, and it's like $101 or something. And so he's like, "Can you just give me 100? Can you just not give me that or something?" He does something funny, but it's just funny. All right, let's do one more, and then we'll call it good. Okay? Good. I remember when I was a kid, like my brother, I was pretty good at math, and then he was like, "You just wait till you get to like the train problems. You think you're good, but I was good. I showed him. I proved him. I think in my little 5-year-old brain, I was like, challenge accepted. I'm gonna kick those train problems butts." And I did. He probably still struggled with them. Don't ask him to do train problems. It'll stress him out. Okay, here's example 3. All right, let's say 2 ships. Ships 400 miles apart at midnight. Headed towards each other. Oh, how romantic. Toward each other. If they collided, oh, okay, maybe not. If they collided, what kind of sick problem is this? At 8 a.m., find the speeds, okay, if one was 20 miles per hour faster. Really, they use miles per hour with ships, but not trains.
You nuts.
I know.
It's gone.
Okay. All right. Do we want to draw a diagram? Does that make us feel better?
There's so many R's and T's on the board. Like,
No.
you guys see all that?
Yo,
PT 7T plus RT.
those are some fast chips. Kind of look like mini putt-putt.
So what's their distance?
400 miles?
400 miles apart. And what do they, and so what's my equation?
20 miles per hour plus. No. Yes.
We're trying to find.
Trying to do, what's our D equation? What's our distance equation? So one of them's going faster than the other, right? So this one, maybe they collided there, and then there's people sinking and drowning. Maybe we've got like a,
I thought that was cat at first.
okay. So what's our distance equation? So we'll call this D of 1 and D of 2. So what's our distance equation look like? All right, D1 plus D2 equals K. In this case, the K is 400. All right, so let's get some R's and T's. Find the speeds if one was 20 miles per hour faster than the other. So how do you say that? How do you say one speed was 20 miles per hour faster?
RT plus, R1. R2 plus 20 equals R1.
Cool. Yep, that works. Does that make sense? All right, now what else do we know? Do we know times?
Yes.
Time of 1 equals, it actually gives the end time again. So midnight to 8 a.m., right? So 8, and that also equals time of 2. So time of 1 and time of 2 both equal 8. So we have two numbers, and then we have an expression that we can just plug in. So let's do that. So remember, this is R1 T1 and R2 T2. Okay, so R1 is this expression, R2 plus 20. T1 is 8. R2 we don't know, but T2 is also 8. So there's our messy equation. So let's distribute that 8, and then let's kind of reverse that so it looks neater. R2 times 8 is just 8R2, right? So we'll have an 8R2 over here, plus 160. I'm just distributing that 8, plus another 8R2 equals 400. So 16 R2 plus 160 equals 400. Continue the equation up here. Subtract 160. 16 R2 equals 240. So far, so good?
Yep.
R2 equals, what is that? 15?
Yeah.
15, and now we're doing miles, so 15 miles per hour. So that's R2. What's R1?
35 miles per hour.
Is that what you're going to say, Micah?
Yep.
Thanks for raising your hand. 35 miles per hour. Good. So these are pretty, all it is just translating and solving. I love that. Because this algebra, it was a tough learning curve. I think for most of you guys, it was a tough learning curve, but you survived it, and now you can use this for your benefit. It's going to be great in Algebra 2. It's going to be great in geometry. But this algebra stuff saves a lot of headaches. Okay? All right.
Flack.